We don't have quite as many options with our algorithms for our subtraction here. So our algorithms we would use to subtract larger digit numbers, 2, 3, 4-digit numbers, that sort of thing. So we've got our standard. I'm going to start. Let's just put up our problem. Right now we're subtracting. I'm going to make sure that we're never going to get any negative numbers. We won't get to negative numbers until chapter 5. So that won't be until we get to exam 2 material. So we're going to stick with our positive numbers. So we should always put the largest number on top if you're ever confused about that when we're working through any of these in chapter 3. All right. So I start off pretty fine in my ones place. 5 minus 3 is 2. But then in my tens place, 5 minus 6 gives me negative 1 that I was just talking about. We can't have that. We can't have negative numbers there. So I'm going to have to think about regrouping or borrowing. Those are two common phrases for this. So I'm going to go to the next place value over, which has a 2. And I'm going to take 1 away from that. I'm always just going to take 1. I don't need any more than that. If I take more than that, then when I subtract, I'm going to be left with a number that is larger than just a single digit. I really only need a single digit as my answer, so I'm only going to take 1. So that 1 over is going to change the 5 into a 15. I know these are in the tens and hundreds place, but you can think about when you steal 1 from the place value over. If this was just, if I just had 25, sometimes it's a little bit easier to think, that is a 20 plus 5. So I would change this to 10. So I change that to a 10, and I have to add this 10 over here to make it 15. So that's really 10 plus 15, and that still gives me 25. So I'm just rearranging where I want the numbers to be. And instead of it staying in the 100 spot or the 10 spot, I'm rechanging where I'm allocating that. Just kind of taking some money from one person and giving it to another, but it's still the same amount. All right, so now I can do 15 minus 6, and 15 minus 6 is 9. And then last in the 100 spot, 1 minus 1 is 0. You could put a 0, you don't have to. And I'm going to get an answer of 92. Now, equal addition is another option. It's something that people don't feel as comfortable with. And I'll be honest, it's a little bit harder to teach because there's not one set method to do it. With the standard algorithm there where all the students are kind of doing the same steps at the same time. With equal addition, you get a little bit more freedom. I'm just going to give us a different problem. Equal addition says we are going to change these numbers to be something that is easier to subtract. Maybe it's something I could kind of subtract in my head a little bit. Now, how you want to change the numbers, that's up to you. That's the part that gets people. I like to think about putting them to what we would like rounded type numbers. So for instance, I might want to change that 156 to be 200. So if I added 44 to it, that would make that 200. So that might make it a lot easier to subtract if I think it, like I said, like about like rounding these things. So lots of numbers with zeros in them. It's called equal addition because what you do to one, you have to do to the other. So I'm going to make it equal. So I'm going to add 44 down here to the bottom as well. So 64 and 44 is 108. So I've added the same number to both of my given numbers in my problem, which happen to added 44 to both of them. What you choose to add is up to you. In just a second, I'm going to rework this problem and add something different. Whatever would work for you adding, whatever would make it an easy subtraction problem, that's what you should add. Now I can subtract 200 minus 108. Hopefully that's something a little bit easier. For instance, I know 200 minus 100 is just 100, but that's 8 less, so that would give me 92. Let me just work this problem again. Same problem, just so we have another example. So again, what I'm trying to do is think about this rounding. So it might be something that's easier to subtract. So you also could think about maybe getting the bottom number. You could think about rounding it. So we could think about trying to get that to 100. Subtracting 100 would be really easy. So to get 64 to turn into 100, I would add 36 to it. And that would make the bottom number 100. What I do to one, I have to do to the other. So now I've got this new problem. This is probably a little bit easier. 192 minus 100. Again, we knew the answer was 92. Most people have not tried the equal additions before. So I've got one down here for you to try. I don't care how you work it. Like I said, I think about getting the number to a rounded, easier number to subtract from. So go ahead and hit pause and give this equal additions a shot. All right. Coming back from pause, let's see how you did here. I'll work it two different ways. There are so many different ways that you could work it. So one way is you could make this 87 try to turn into 100. And what you do to one, you have to do to the other. So I took this problem, I added 13 to both of them, and then it was pretty easy to subtract. It's probably honestly the quickest, the easiest one to do out of all the ones I tried with this particular problem. If you can get that second number, the one on the bottom, to turn into something like 100, 200, something that's really easy to subtract, that would probably be easiest. You also could, another possibility that I did was I added just 3 just to get up to 90. That wasn't too bad. And so then 8 minus 0 is 8, and 22 minus 9 is 13, and that got me 138. Those are probably the two easiest ways that I work the problem. But anyway, anything as long as you're adding the same number to the top and bottom, technically would be an equal additions.